All right, let's take a look at some general equations. So in this video, we just want to look at some of our basic equations, how to solve um, something of a basic form of ax plus b equals c. If you looked at my introduction to equations video, you see that we started off first figuring out how to solve x plus b equals c, then it was ax equals c, and now we're kind of putting it together and going ax plus b equals c. We're basically just adding a little bit more level of difficulty to each new equation and seeing that they're still solved with the same basic set of steps. And then we're going to summarize at the end with those basic steps. Okay, so anytime you have something of the form ax plus b equals c and you want to solve for x, you should all be thinking, well, don't I want to move the b over and then divide by a? Yes, that's exactly what you want to do. So for instance, this stuff. You can move that 2 over, right? So you have to add 2 to both sides, and you get -9, and then you have to divide by 3/4, which is really meaning multiplying by 4/3. Now again, if you're still having difficulty multiplying by reciprocals, then do what I always do, just get rid of fractions, and you get rid of fractions by multiplying by the bottoms. So instead of doing it in one piece, multiplying both sides by 4/3, just start by multiplying both sides by 4. The 4's cancel. You get 3x equals -36. Then you can divide both sides by 3, right? And you get x equals -12. Simple, easy, just took one more step than doing it this way. So until you get comfortable with those reciprocals, just do multiply by the bottom of the fraction and then simplify. All right. Now, most algebra books and most algebra teachers will teach the idea of the least common multiple or the idea of the least common denominator, which is just the fractional version of the least common multiple. And this is the way to kind of simplify things and get answers with the least number of mathematical moves possible. As far as multiplying by something or dividing by something, do that with the least amount of steps possible is only done if you grab the least common multiple. But here's the problem. A lot of students struggle with figuring out what the least common multiple is. So there's places there to make mistakes. And then they have a lot of problems, let's say, applying that technique and figuring out, okay, so which number do I multiply by 2 and which number do I multiply by 3 because I'm trying to get a 12 total. That kind of stuff is really easy to mess up. So instead of struggling with least common multiples, I tell my students, you know what? Screw it. Just find any multiple you like. And the easiest one is just do a multiple of the two numbers you're dealing with, right? If you're dealing with 3 and 4, sure, 12 is the least common multiple. But if you're dealing with 6 and 4, again, 12 is the least common multiple. But if you don't see that, just do 6 times 4, get 24, and at the end you're going to have to reduce by dividing both sides by 2. Ooh, big deal, dividing by 2. Oh, that's so difficult, right? The reason why I'm trying to kind of make light of this is for most people, they have less chances of making mistakes if they multiply by 6 and 4 and then divide by 2 later than they do trying to figure out that 12 is the least common multiple, and then I multiply 6 by 2 and 4 by 3. Right? It's all that extra different multiplication where you're going to screw something up. So it's safer to sometimes not do that. So yes, using the least common multiple will help you clear denominators on fractions, but again, oftentimes it's easier to just multiply by the bottoms of each fraction rather than worrying about the least common multiple. Okay, now that we've talked about all that, let's look at an example. So we've got 3x minus 7 equals -5. We add 7 to both sides, right? We get 2 on the right. We divide both sides by 3. We get 2/3. All right, no fractions there whatsoever. So that was kind of a stupid example. Let's look at one that actually has some fractions. Let's look at this, right? Now, the kind of common wisdom says, well, we've got to find the least common multiple between 4 and 6, and that's 12. And then I got to multiply this thing by 3 to make it, or I got to multiply by 3 over 3 to get it over 12. And then I got to multiply this by, no, don't even bother. Instead, and when I summarize everything later, you'll see that the first step I always say in solving any equation is get rid of fractions, decimals, and grouping objects. And grouping objects are parentheses, absolute values, radicals, any kind of root, like a square root, cube root, anything that groups terms together, right? Anytime there are two or more terms that are lumped together, right? So inside parentheses, you've got x plus 3. That's the grouping object, right? Inside absolute values, you've got x plus 2. That's a grouping object. If inside the absolute value is just x, it's not really a grouping object, and you don't have to deal with it right away. You can deal with it later. And by the way, with my set of steps, you don't have to do them in the order in which I present them, but the order in which I present them does tend to make your life easier. All right, so we want to get rid of fractions, decimals, grouping objects. In this case, we have fractions. We need to get rid of them. So instead of coming up with the least common multiple, let's just go screw it. I'm just going to multiply everything by the biggest one. So there's 6. I'm going to multiply everything through by 6. Multiply this by 6. 6 times 3 is 18 over 4, right? 6 times 2 is 12, and this equals 1. Now you go, okay, well, 18 over 4, that reduces. That's 9 halves. And if you didn't see that, that's fine. It'll all reduce out at the end. Now that I've reduced it, I now have to multiply everything by 2. If you didn't see that, you multiplied everything up here by 4. So I'm going to do both of them. You'll see that it works. So on this top one, we're going to multiply everything by 4. We're going to get 18x plus 48 equals 4. This one, we multiply everything by 2. We get 9x plus 24 equals 2. Now, up here to solve this, wouldn't we move the 48 over? We would subtract both sides from 48. So we're going to get 18x equals negative 44. Then we divide both sides by 18. We get x equals negative 44 over 18. And then this needs to reduce, right? They're both divisible by 4. So, I'm sorry, by 2. So we go negative 22 over 9, and you go, okay, 9, well, that's only divisible by 9 and 3, and 9 and 3 don't go into this, so that's as reduced as it's going to get. Okay, what about this one? Well, if we do this one, we move the 24 over, we get 9x equals negative 22, divide both sides by 9, x equals negative 22 over 9, the exact same answer, and it saved us a step, right? We didn't have to divide by 2 in the end, but big deal. How much extra time did it really take? So my point is, don't worry about finding least common denominators. Just multiply, multiply, multiply to get rid of all those fractions. Get it down to a much simpler, right? Isn't this a much simpler looking equation to deal with? Now you get it down to something of the form ax plus b equals c, where a, b, and c are all whole numbers. Then you just shuffle things around and solve for x like you do normally. That's something, you can solve ax plus b equals c all day long and not get that wrong. So it just makes your life easier, less chances of making mistakes. Okay, so first piece of advice, don't do least common multiples unless you're really good at it. Just multiply by the bottoms of each fraction. Let's look at one more example, a dreaded word problem. We want to determine the total cost of production. An economist uses the equation T equals U times N plus F, where T is the total cost, U is the unit cost, N is the number of units made, and F is the fixed cost. It's a very standard equation, right? Unit cost times units produced plus fixed cost equals total cost. Sometimes it's called variable cost and fixed cost. So instead of, unit times N, they take that whole thing and kind of say that's your variable cost. But you get the idea. So now we need to find the number of units made during a month in which the total cost was 9,000, the unit cost was 25, and the fixed cost was 3,000. Well, now it's just a matter of plugging those things in and solving for what you don't know. The unknown here is N, right, the number of units. So we plug it all in. There's my total cost, there's my unit cost, there's my fixed cost. Well, if I want to solve for N, don't I want to get this 3,000 on that side? So subtract them from both sides because we're going to isolate our variable. So here's 6,000 equals this. Divide both sides by 25, and we get an answer of 240. Now, the reason why I like this equation is I want you guys to realize that, hey, look at that. The N, the thing that I'm looking for, is on the right-hand side of the equation. It does not matter. So many times, especially in grade school, you get stuck in this pattern of X or whatever you're looking for is always on the left. It always has to be X equals blank or N equals blank. No, it doesn't. Your variable can be on either side of the equation, so don't waste brain power and time shuffling all of your variables to the left-hand side of the equation when it could be easier to leave them on the right-hand side. All right, so that's a second tip. And then let's go look at some more examples in our other video. This is it for this one.